Welcome everyone. Myself Professor Kunalsinh from Saffrony Institute of Technology. Today we will study one FEA numerical having a case of static bar with penalty approach. Now I would like to clear that there are two basic methods to solve this numerical. One is known as a elimination approach and another is known as penalty approach. So on the base of elimination approach, I have made another video, you can watch that. And for the penalty approach, let's begin. So the numerical states that a stepped bar is subjected to the axial load of 5 kilonewton. So this step bar is having a axial load of the 35 kilonewton, and this 35 kilonewton load is acting along with his axis. Okay, so what they're asking, we need to determine the nodal displacement, reaction force and stresses. Now nodal displacement means which every nodes how much it gets displaced. Okay, and another we need to find the reaction force. So you can see that this bar is attached to the wall at both sides, so we need to figure it out that how much reaction will occur at this both walls. The data given are is E, that is called as elasticity, is 200 gigapascal. So now let's see that what are the data given here. First, the data given is that F1 35 kilonewton. So we are converting it to the 35 into 10 raised to 3. Another data given is area, which is 400 mm square, 300 mm square and 200 mm square. So this area is listed here. Then another is elasticity, 200 GPa. So that GPa is converted into the Newton per mm square. And length of the first element, second element and third element. So it is the 400 mm square. It is noticeable that here we can just easily divide this bar into the number of elements. That is first number of element, this one we will call second is, and this one as a third element. So as the rule says that first we need to do a discretization of the bar. So let me show you that how we can discretize this bar in the 1D formula. So you can see here that I have drawn this bar as a simple line. So what we need to do, you have to draw this bar as a simple line. This number 1 is representing this element number 1, this number 2 is representing element number 2 and this represents element number 3. Similarly, accordingly, this number 1 represents the element node number 1, this is node number 2, this is node number 3 and 4 respectively. It can be seen here 1, 2, 3 and 4. Also the force acting on this node number 3, which is the 35 kilonewton, is mentioned here. It is 35 kilonewton here. Also U1, U2, U3 and U4 are the displacement of these nodes. That these nodes, how much these nodes will move on after acting this force are the displacement. And R1 and R4 are the reaction forces at the node number 1 and node number 2. Why we call it as a R1? Because it is attached to the wall, so some kind of reaction will occur on this wall. Similarly at this side. So these are the things. So I have listed it here also. So this was the first step. Second step is to elemental stiffness matrix. So we need to figure out that how much stiffness will get generated per element. So for element number 1, 2 and 3 separately we have to make the matrix. So for that there is a standard equation. If we are calculating for the K1 for the element number 1, then area of the element number 1, A1, elasticity and length of the element number 1. So what is the area and length of this element number 1? Area is 400 and length is 400 and E is 200 into 10 raised to 3. So we are putting those values here respectively. 400 is area, 200 multiplied by 3, 400 and 1 minus 1 minus 1 and 1. This is the standard matrix. I mean that this is called as a standard equation also. Okay, so 1 minus 1 minus 1 and 1. So now we are multiplying these values with this one also. So we are getting this as a answer. So this will be a stiffness matrix for the number 1. Similarly for the element number 2. So for element number 2, you can see here, so area is 300 and length is 400. So by replacing this equation here, same equation what we have used for K1 will be the K2, just replace those values. So 300, 200 and 400. Finally you are getting this as a answer. So this will be the elemental matrix for the element number 2. Similarly for element number 3, A3 E3 by L3. So what is the A3? Area number 3 is 200 mm square and E3 is 200 and the length is 400, right? So we are just replacing those values here, nothing new. It's very simple and very easy to understand. 200 into 200 into 10 raised to 3 by 400 and multiplying those values with this 1 minus 1 minus 1 and 1. So we are getting 15 into 10 raised to 3, 2 minus 2 minus 2 and 2. You have noticed that I have tried to make 50 into 10 raised to 3 as a common in all metrics. You can see that 50 into 10 raised to 3 is here in K3 also. In K2 also I have tried to do it, and in K1 also I tried to do it. So just try to do this thing, that if you can keep a common value at outside, then will be fine. Otherwise it's okay, you can move forward. So until this we have found K1, K2 and K3. So now next step will be the finding a global stiffness matrix. What is the global stiffness matrix? It is the summation of K3, K2 and K1. So what we need to do, we need to sum up this all three metrics together in one matrix. So you can see here what I have done, that these values are the of K1. So you can see that what answer we are getting for the K1 was this. Okay, I will show you it here also. See, K1's answer was 4 minus 4 minus 4 and 4. So that we have put it here. K2's answer, so K2 matrix was 3 minus 3, 3 and 3. So value were 3. So you can see here that I have put those values here, right? This is the summation of both. And similarly K3 is visible here, 2 minus 2 minus 2 and 2. So it will be at exactly adjacent corner of this matrix, right? So for simplification, let me delete these values for you. It will be easy to understand. Okay, so after that what I am doing, I am simplifying this matrix. So how I am simplifying? 4 is 4, minus 4 same, 0 same, 0 same, minus 4, 4 plus 3. So 4 plus 3 will be here as a 7, minus 3 minus 3, 0 0. Here also 0 will be 0, minus 3, and 3 plus 2 will get replaced by the 5, minus 2, 0 0 minus 2 and 2 multiplied by 5 into 10 raised to 3. Do not forget to multiply it by 5 into 10 raised to 3, because every matrix has the 5 into 10, 50 into 10 raised to 3 as a multiplication. Okay, after that step number 4, find out the global load vector. Global load vector means forces acting at each element. So F1, F2, F3 and F4. So if you see the discretization image, so you can see here that there are 4 nodes, F1, F2, F3 and F4. Now F3 has some value 35. Okay, F1 is R1, F4 is R4 and F2 is nothing right now. We are not figuring it out right now. Okay, so keep it in mind that if you are going for a penalty approach, right? So for penalty approach, keep it in mind that despite of the given force in the numerical, there is 35 is given, other forces will be counted as a 0. This is the standard rule. So if F3 is 35 into 10 raised to 3, then F2, F1 and F4 should be 0. Then and then only you can proceed for the next procedure of penalty approach. Okay, so 0 0 35 into 10 raised to 3 and 0. In numerical also 35 into 10 raised to 3 kahan se aaya? From where we got, you can see it here, 35 kilonewton is acting on the F3. Okay, so now let's move on to the next step. We have found the global load vector. After global load vector, you need to find global displacement vector, that is known as a UN, and these all values are unknown to us, U1, U2, U3 and U4. What is the displacement vector? Displacement vector means that after applying a 35 kilonewton node, how much this node will move from its position. So it will be called as a U1, U2, U3 and U4. How much mm it will move from here. Okay. So now let's move on to the global displacement vector. This is U1, U2, U3, U4. Now 6. That is the addition of all the matrices. The standard equation for this one is K, which is here. This is global stiffness matrix multiplied by UN. This is U1, U2, U3, U4 and is equal to force global load vector F. So this one will be here. So I am just replacing those values here for you. So you can see it here that I have replaced this value here. K is here, U and F is here. Now penalty approach. For the penalty approach, the first step is to use the standard equation of penalty approach. The standard equation is C. C is known as a penalty actually. So C is equal to maximum of Kij multiplied by 10 raised to 4. So now what you have to do, you have to see this whole global matrix, global stiffness matrix, and find out that which value is the bigger one, which is the highest value from it. So here I can see that here the 7 is acting as a highest value here, right? So I am replacing this 7 with this here and multiplying it with the 10 raised to 4. So the answer will be a 70,000 for me here. Okay, so this will be the standard value for me to apply the penalty approach. Okay, this is the step 1 only. Now step 2, addition of the C with the extreme edge corners. Now what I have to do, I have to add this 70,000 to this both extreme edge corner. So which one will be the matrix extreme edge corner? Corner number 1 and corner number 2. I will add this value to the corner number 1 and corner number 2. So I am doing the same here. You can see that there were the 4 plus 7,000 is equal to 4 plus 70,000. Okay, minus 4, all the other values are the same, and similarly at the another extreme edge corner 2 plus 70,000. After simplifying it, what it should look like this, it should look like this: 70,000 minus 4, 0, 0, minus 4, 7, minus 3, minus 3, and this will get simplified as a 70,002, and this will get simplified as a 70,004. The rest of the values are here, same things we are repeating here. Okay, so after the step number 3, we'll move to the another step. Now at another step, what will be our target? First of all, here the penalty approach started and ended, you can say. Now what we have to do, we have added already penalty. Now our target is that to save this adjacent column. Now what I will do, I will take care of this adjacent column and we'll try to make this all value as a 0. Are you getting my point? I will try to make these all values which are out of this adjacent column will be counted as a 0, and I will do it 0 by simple method, that is called as a simply that just a multiplication and addition. Gaussian elimination method is different, but here we'll do another method. So for this one, what I will do first, what I will do, I will try to make this 4, this one 4, and this minus 2 as a 0. So if I want to do this minus 4 as a 0, what I have to do, I have to multiply the row number 1, which is this row number 1 should be multiplied with the 4 divided by 70,004. Okay, so what will left here, this 70,004 will get deducted here and positive 4 will left here. Now this row number 1 will be get added into row number 2. So the answer of plus 4 will get added to number 2. So what will be the answer? Will be the 0. That is my target. Similarly I am doing here. You can see that here is minus 2. So what I will do, I will multiply this point with the 2 divided by 70,002. So what will happen? This will get deducted, positive will left here. So the fourth row will be added into the third row. So if I add +2 here, so 0 will occur here. We can see it here also, stepwise procedure here. So you can see here, I'm zooming it out for you. Now you see this 70,004, right? This 70,004 is here, is multiplied by 4 divided by 70,004, which I am mentioning it here. I am adding it with the -4, which was the previous value in the matrix. So adding it the -4. Similarly, the same method I have to apply for this. This is -4, but with this -4, as per rule, I have to multiply it by the 4 divided by 70,004. Okay, which I am doing it at, and +7, which this value, the value already I have in the matrix. Similarly, -3 will be the -3. Why? Because 0 is multiplied by anything will have a 0, and if I will add or subtract 0, then answer will be the same. So here similarly for the 0. Similarly inverse, I am doing the same thing. 0 will be 0, -3 will be -3 because 0 is here. Here also -2 is multiplied by 2 divided by 70,002. Here is the 2 divided by 75,002, and this 2 is here. Okay, and in addition to the 5, so we are adding it with the 5. Same here, and I'm repeating the procedure here, and the answer will be like this. So if I try to simplify this thing, okay, I'm just zooming it out for you. If we will do a simplification of this, then this step, which I am just making as a round here, this step will become a 0, which was our target. This will turn into the 6.99. Similarly, this will turn into the 4.99, and this will turn into the 0. So you can again highlight this adjacent row that I want to save this row right now. Okay, so now what I'll do, I'll try to make another values which are here, 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 and here as a 0. So what I will do, I will first target at this one now. Next step, I will make it as a 0. To make it as a 0, I am adding 3.699 with the row 2. So this is the row number 2 for me. Here I am adding a 3 divided by 6.99 multiplication of this, and adding this value into this row will be row number 3. So doing the same thing here, what I will get, you can do this multiplication and all the answers in your note, and you will get this answer, that you can see that our target was to make -3 as a 0, and we are getting achieved here. Okay, and after multiplication of this value 3.699 with whole this row, right, and addition with this row, I will get this as a answer 3.71, which was previously 4.99, will remain 0. So now I'm just deleting it for the comfort. Now again I am just highlighting this row. So what's left now? The left thing is that here, that -3, -2, and -4. So now in next step I will work on this. I will make this as a 0. So let us do it. Next target. So to make it 0, I have to multiply this, this row to the 3 by 3.71, and the answer what I am getting, I will multiply, add with this row. So row number next. Okay, so that should be the answer. So the ultimately in next phase what I am getting this as a answer. So you can see that this 3 got turned into the 0. So now this 3 is as a 0, and now left values are -2 and -4. So now again you can notice that this values, that what 3 divided by 3.71, I am multiplying with the row number 3. So same thing I have to do it here also. So I have to divide and multiply 3 by 3.71 with 35,000, and what answer I am getting, I need to add it with this value which was 0. So take care that I have to multiply it here also, like that 3 divided by 3.71, and those values should be added, x जो भी value है that value should be added here, and we'll get answer. Okay, so similarly I have to do it in this matrix also. After the same thing, because now what left, that this one -2 and -4. So for -4 I am adding the 4 by 6.99 by multiplying it with the row number 2 and adding in the row number 1. Similarly, to make this 0, this as a 0, I will multiply this row number row number 3 with this value. Which value? 2 into 3.71, and we'll add those answer into this one. I will do it for this also. So what I am getting? I am getting this kind of matrix. Now you can see that everything is simplified. Our target was using the penalty approach was this, to make this as a biggest final value, and this everything as a 0. So you can see that u1 has some certain value, u2, u3 and u4. So if I will simplify this equation, you can see that for u1, 50 into 10 raised to 3, 70,004 multiplied by u1 and is equal to 16154.8. That is the answer here, 16154. Similarly, another one, second one, let's see that for second one what we can do. 50 into 10 raised to 3, 50 into 10 raised to 3, u2 multiplied value is 6.99, and the value is 28269.98, 2826, and so on. I have listed those values. So you have to just write it as a same equation by adding these values in this manner and this, right? And by simplifying this, I am getting these answers. u1 will be 4.61, u2 0.08, u3 and u4. This you can do by just simplifying these equations, okay? And now as this step is over, we got that displacement of each node. This is the answer of the requirement which was required in the numerical. And now the next requirement, stresses in each element. Okay, so sigma we need to find stresses in each element. So the standard equation for stresses in each element is E divided by L minus 1 into UN. So this is per node and per element. So let's see for the first element. For first element, sigma will be E1 by L1 minus 1 into 1, U2 by U1 by U2. Now if I will simplify it, so what happens, that I will multiply this minus 1 with U1 and this positive 1 with the U2. So I should get this equation. Is it easy? E1 by L1 minus U1 plus U2. Now substituting those values, E1's value is 200 into 10 raised to 3 and L1 is 400. Similarly, the U1's value is 4.614. You can see here, I'm just highlighting it, 4.614 into 10 raised to minus 6, and negative sign is here because the equation is here, plus 0.08077, which is here U2. So I will get U1 sigma 1 as a 40 into 40.39 Newton per mm square. Similarly, I am doing for the element number 2. You can see that it's a simplified equation like this only. The replacement of U2 and U3 will be there. So I am just putting those values from U2 and U3. So these values I will put, then I will get answer for the sigma 2, 53.86. And for the element number 3, E3 by L3, that is minus U3 and U4. Why? Because E3 sigma 3, the element number 3 is connected with the two nodes, which 3 and 4, hence we are considering it as a U3 and U4. Similarly for the 2 also, with which it is connected with the second number node and third number. And similarly for the 1 number also, it is connected with the 1 number node and 2 number node. Hence we are just considering U1, U2, U2, U3, U3, U4. So simplifying it, we will get the answer that 94.25 Newton per mm square, and for correction purpose this answer will be negative. It shows that that element is under compression. Okay, so if I will sum it up all the answers, sigma 1, sigma 2 and sigma 3, this will be the answer. Okay, so the answer what they asked was for stresses in each element. is here. Okay, and the next question was reaction forces. So the next step will be to find the reaction force, and reaction force has a very simple equation. What is that equation? R, which is called as a reaction, then minus C and multiplied by U. So what is minus C? Minus C is the penalty. If you remember, then let me go up and show you that where is the C right now. So C was here. You can see that this is the C using the penalty approach we have found. So what was that value? 70,000. Okay, 70,000 was the penalty of that one. So we will replace those value with here to find the reaction force. So we will come to know that what will be the reaction force here. Okay, so that, and U is the for which point you want to find out the reaction force. So we as we have seen in the numerical and figure also, let me go up and show you that you can see that we are interested to find the reaction force here and reaction force here. So R1 is associated with the U1 and R4 is associated with the U4. Okay, so we will put those values U1 and U4 and simultaneously we can find the answer for it. So let's move on there. Okay, so for first R1, so it will be a minus C1 U1. So C1's value will be minus 70,000 into multiplied by 50 into 10 raised to 3, and U1 value is 4.61 into 10 raised to minus 6. So the reaction at this point will be minus 161. Similarly for the another one, last point, that minus C U4. So it should be a minus 70,000, 50, 10 raised to 3. U4's value is here, and then by simplifying we can get this as a answer. So hence that these are the required reaction force. So we can write reaction forces at both ends. Okay, so this is how you can just solve any static bar problem which we have seen right now by using a penalty approach, and elimination approach can be used also. So in next session we'll come with some new idea, some new topic. Till that, goodbye.